So, hi, Dr. Tan and my fellow classmates. Today, we're going to present our assignment on deep learning for data science. So first, who are we? My name is Mei, together with Yifu and Yun Zhang. We are from Department of Computer Science, and actually our projects present a mobile application for leaf classification using deep learning approach. So this is our poster generally. So as we cannot present it physically, so I think that this poster is roughly too big and you cannot see clearly. So to let you see clearly, so we split into sections. So let's proceed to the next section. So to let you have a bigger picture on what's our app really doing and what's our app about, so let me present you a general idea. So it's a mobile application which works for Android and iOS platform for leaf classification using deep learning approach. So it's identify leaf species from images, and the images uploaded will be pre-processed, resizing, convert to tensor, and lastly normalization. So the tensor will be add as the input for the ResNet 152 model to classify the leaf species among 112 leaf species. So what's the accuracy? After fine-tuning the ResNet 152 model, it is around 97%. So why do we come to this project? As we've seen several phenomena and problems in our life. So first, leaf is the foundation of studies of biodiversity richness of a region. However, traditional methodology is repetitive, inefficient, and there sometimes may be error as it is a human identify. Instead by D. Carvalho and Hastings in 2007. Most of the time, it's the expert who can differentiate the leaf species. What if the public tend to know the leaf species when they are hiking? Or maybe they went to a forest? So LeafSnap has seen this issue earlier than us and has started an interest in the leaf recognition, which in year 2012 by Kumar and his team. However, the image acquisition used by the LeafSnap app is restricted to the background of input image plus clean. This is because their algorithm is on image processing, and they need to pre-process the image, whereby they extract the shape feature of the leaf from the image. So it is hard to come up with the traditional computer vision algorithms when number of classes is huge and when the image clarity is low. So our projects aim to encourage the study of plants among public to recognize the leaf under any extreme conditions such as over or low illumination and blurry image to improve the existing leaf species recognition system with improved classification results. So 3 applications has been reviewed. The first one is Planet in year 2013 by Mount et al. The second is the LeafSnap, which has over 1 million users, Kumar et al. In year 2012. The third one is the Vietnamese medicinal plant search by Le, Trang, and Hong in year 2014. So the mobile platform for Planet and Vietnamese medicinal plant search is Android, while LeafSnap is iOS. However, the highest number of species identified is LeafSnap, which have 184, while for the Vietnamese medicinal plant search, as they focus on the medicinal plant in Vietnam, so there are only 55 of that. Proceed to the image preprocessing. The Planet have an assumption where it is a restriction whereby the input image must have a single leaf in the center and the background must be uniform. So the LeafSnap, they pre-process by color-based segmentation. So for the Vietnamese medicinal plant search, they detect the pixel and remove it. So they only have the shape of the leaf and they did on leaf orientation normalization. And for the feature descriptor, Planet and LeafSnap are using the shape descriptor as well, where The planet is using multi-scale triangular representation, and this map is using curvature-based shape feature. So, planet also use the descriptor of the selling points of the leaf, whereby user can actually choose whether want to identify by leaf margin or combination points of the leaf. So proceed to the Vietnamese medicinal passage. They are using improved canon descriptor which proposed by them. So the classifier for planet and leafset is the same, which is the nearest neighbor. For the Vietnamese medicinal plants, it support vector machine. So next, I will pass to Yongzhuang to explain our system design. Thank you for listening.
My name is Go Yongzhuang. Now I'll be talking about the system design. Firstly, speaking about the model construction, the very first step is to load the leaf images from hard disk to memory. Next, the images will be splitted to training set, which consists of 80% of the total images, validation set, and testing set, which both of them made up of 10% of the remaining 20%. After that, the images will be pre-processed. First, the image will be resized according to the model input size, and after that followed by the random horizontal flip and making it to tensor. Lastly, normalize it with 0.5 ratio. Next, it will be the build network phase, whereby it consists of 4 models, which are ResNet 152, Inception v3, VGG19 with batch normalization, and GuliNet. All of these models will come with their respective cross-entropy loss, Adam optimizer, and step learning rate, with the step size of 10 and gamma of 0.1. Next, it will be the training phase. All of the models will be trained for 30 epochs. There will be a visualization of the training loss versus iteration graph, and also the visualization of training and validation accuracy versus iteration graph. Lastly, it is the testing phase. All of the models will be tested with the testing set, which in order to compute the precision, recall, and F-score. The best model will be selected and being saved for the leaf classification in the mobile application. For our case, ResNet 152 is the best model. This model would be used in the GCP Python server, which is built by using Flask for the leaf classification. Users can use the mobile application to take photo on the leaf or pick the leaf images from their album, and the mobile application will send a HTTP request to the backend server for leaf classification. That's all. Thank you.
My name is Lenny Fu, and now I will be presenting the result from the experiments on model. The diagram shows the training loss and the accuracy of training and validation sets on ResNet 152 model. Based on the diagrams, we can observe that the model is fully converged at around iteration 215. This is because the loss and the accuracy are stagnant after iteration 215. Furthermore, from training and validation accuracy diagram, the accuracy is fluctuated a lot before reaching the optimum point. This is because the model is deep and the amount of parameter have to be tuned is high. Moreover, based on the diagram, we can conclude that the trained model does not suffer in overfitting or underfitting problem because of close training and validations accuracy across the training iterations. Next table shows the micro and macro average precisions, recall, and F-score of the model on testing set. All micro and macro average precisions, recall, and F-score are above 97%. Important to note that micro average precisions, recall, and F-score share the same value, and this is because in multi-classification problem, false positive is equal to false negative. Next table shows the performance of few selected models on the testing set. The model includes ResNet 152, Inception v3, VGG19 with batch normalization, and lastly GoldNet. Based on the result, ResNet 152 achieved higher performance on all the evaluation metrics compared to other models. Hence, ResNet 152 is chosen as the backbone for leaf classifier in our project. In summary, we have learned to build a high-performance deep learning-based leaf classification mobile application through Android and iOS-supported structured framework for a total of 112 leaf species. The backbone network applied is ResNet 152, which performs above 97% for all micro and macro average, precision, recall, and F-score on testing sets. In future work, we hope to increase the number of these species detected, deploying a real-time leaf classifier, and also enhancing the current user interface. With that, we have finished our poster presentations. Next, I will pass to Sume for the demonstration of our mobile application.
So I'll proceed to the demonstration of our mobile application. First, our application is named Extreme Leaf. So click into application. This is our splash screen. This is our main screen. So we have two choices to upload our image. One is camera, another one is local gallery. So we are going to choose gallery for this time and select one image and then press upload button. So this is our classification result, and back to the main menu. So this page is for you to upload your images for a classification, and then these pages have a list of plant species which our system can identify to show to user. So this is the details of our leaf species. So that's all for our mobile application and also our presentation. Thank you for listening.